Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. Detect security threats in minutes before it affects your customers with Datadog's newest security monitoring product. Teams can investigate security threats and malicious activity in real time using 75 plus out-of-the-box detection rules and detailed observability data, metrics, traces, and logs in one integrated platform. See it for yourself by signing up for a free trial and receive a Datadog t-shirt by visiting securityweekly.com/Datadog. By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Security Weekly is ramping up our webcast and technical training schedule for the rest of 2020. In September, you can learn how to extend the enterprise network for remote workers and protect your home network. You can also find out why traditional data security can't be zero trust, and you can learn how to reduce the blast radius of your cloud infrastructure. Visit securityweekly.com/webcast to see what we have coming up, or visit securityweekly.com/on-demand to view our previously recorded webcasts. And that brings us to the news. And speaking of visibility, I know, John, you always have your eye out for container security and Docker escapes. And I think you've caught one for this past week that you'd like to share with us.
I do. And speaking of visibility, I didn't mean to be quiet on that last segment. I just really enjoyed the conversation, so I'll let you guys go. Yeah, this is one of my, I found this one a week ago, and folks who have worked with me or customers who work with me know how much this type of thing really irks me. So there's a blog post from, looks like a pen tester, Red Timmy. I haven't heard of them before. But long story short, they were working with a customer who had decided that they're going to try and use Docker sockets inside Docker containers, which is a horrible idea. And the rant, for folks who haven't heard me, I must have done this on here before, but the default way of using Jenkins for doing CI builds wants to do what's called Docker and Docker, which basically means you put the Docker socket for the engine inside a container and then let that container control Docker and spin up other containers. The reason this is horrible is because there's absolutely zero security on it. There was no security in the design. They just left there's a nice open thing, and I think there's an API. I think Twistlock has a proxy to put on there to try and secure it, but all you need to do is compromise that container, and you've compromised everything on that host. This is where a lot of the miners start working through, if they're able to get into a container that has that in there, or if someone leaves just a Docker socket on a TCP socket, it's a Unix socket by default. This is something you want to use as little as possible and keep it as secure as possible over in a corner. This is partially why Red Hat and Google have come out with ways of doing both container builds as well as running containers without having a socket exposed like this. It's you can sense it's not really a great thing. And I've had really significant fights with very large customers before about, you don't want to be doing this at Qualys, and they wanted to do it, and I was dragged kicking and screaming, and we eventually supported it. But it's really, you're setting yourself up for failure. Anyways, this blog post, this particular customer, whoever it was behind this, they decided to write their own proxy on that socket. So the idea being, hey, if we control what that Docker engine's able to do, so we say, don't start containers, or, don't mount certain things. Because basically the use case is, if you run a container and as a mount point, you mount the root volume of the host instance, I'm now able to modify password files. I'm able to start and stop services. I'm able to do whatever I want, right? So that's how the exposure is, or part of the exposure platform. And I know Matt's over there somewhere nodding with me because don't run as root.
No root, yes. I've just been waiting for a break.
But so basically what these guys with this proxy decided to do is, okay, we're going to figure out all those things which you're not supposed to do, and we're going to blacklist those so that only certain things can be run in this container. Sound familiar to people? And so the pen tester got in there and they started playing, and it's a decent blog post because he starts talking through, we've obviously been in tune this year with blog posts that they sort of walk through how we think about this type of thing, right? So you start and you see like, okay, there's my basic example, mounting a volume, that works. Okay, let me try to mount the root volume, and that didn't work. So he tries different ways, and he starts screwing around. He eventually figures out a way to be able to write to the root volume, and once you've got that, you've got the box, right? So that's the blog post. But the story behind this is, as with crypto software, writing your own security software, this is, Mike and us, we've been talking about threat modeling recently. This is, again, an example of that, of not really threat modeling, right, but actually sort of whiteboarding or thinking through all the various examples of how could this be used in a bad way, and then making sure your software actually catches that. Can be pretty difficult, huh? So that's sort of the case around this. You don't have to, very, very seldom can you actually really justify using Docker and Docker. There's just really other ways of doing this. If you're going to write this yourself, don't blacklist, whitelist, allow through just the very specific things you want to do. But that's sort of the blog post in my rant, and I'll take a step back if you guys have thoughts about it.
I liked it too. And the thing that stood out to me is that, yes, I love these types of blog posts that give sort of that attacker's mindset of, here was my end goal, and here were a couple steps to get there, including false starts. I tried this and it failed, so I'll try this and it failed. So listeners, if you have other examples that you'd like to share with us to highlight, we'd love to hear it. And the other thing I liked about this one in particular is that the bypass here wasn't a type of injection attack. It wasn't sadly, it wasn't a path traversal dealing with sockets. It was more of the set composition of the reverse proxy. So they said, sure, we're going to have this allow list. They're only going to allow certain paths. But oops, we forgot to say, we don't want to just allow only these things. And by the way, all these other paths as well, like the / to host, it should have been only allow what we've mandated is on this allow list and exclude all the others. So it's a good example, just what you were saying. If you're going to implement a security control, you have to have some good, robust testing around it too. And I also want to say that just some good normal acceptance testing, QA testing, would have found incidentally this type of security bug. So it's a bit surprising that it comes out this late in the game, or I guess maybe unfortunate, I should say.
Yeah, and it's for folks curious about Docker, there's this is interesting from the point of view of there's some stuff in there I hadn't seen before in a previous blog post. So the Docker API is actually a HTTP API that goes either over a TCP socket or by default, like I said, Unix socket. But they actually have some curl commands in here to show you how to do it, which I don't think I've seen that before. So usually when people start playing with this, they have to write a little bit of Go or Python or something to actually interact with that. But here's how to do it in curl. So I thought that was sort of neat. But back to your point, Mike, Docker API is not simple, right? It's fairly complex, and sort of similar to like if you try to create. Here's a little experiment for the kids at home. Try to create a regular expression to correctly identify an email address. It's super difficult. It's in the back of the wherever it's in the back of the O'Reilly book for regex, right? It's really long to actually get it right, and that's because email is complicated, even though it sounds so simple. We were talking about DMARC recently, and it's sort of similar for this thing. To actually whitelist this correctly, an API this complex is a pretty good trick. So maybe fall back to our standard AppSec concept of don't allow people to specify what they want, but give them 3 or 4 choices and then builds that for them would probably be a safer way to do this as well.
No, absolutely. And I think there's additionally to segue into other topics about trying to make sure people or developers do things a safe way. We also have another pretty nice write-up about the attacker mindset, a little bit of methodology about a researcher who was basically just poking around GitHub and doing search dorks for, in this case, a lot of health information. And their write-up went through, I think it was about 9 or 10 different companies that they found various amounts of records from, but essentially boiled down to a combination of hard-coded credentials, hard-coded secrets, or then also just having some access to source code, and in one case finding a vuln within some PHP code, and in another case finding some code that actually already had a web shell in it. So I think that also speaks to that. What can we as a security industry do to make it easier to manage credentials that are not hard-coded within source, or give alternatives to doing so?
Yeah, I mean, this is one of Paul's biggest, nightmare scenarios, right? You leave a set of credentials embedded in your code because you're trying to authenticate to stuff, and then you push it up into your GitHub repository that happens to be publicly accessible, and then next thing you know, everybody's got your credentials. But that's exactly what they're talking about here, right? And so how many times does this happen? Obviously, a lot. Is not only are we leaving embedded credentials there, we're pushing them to repositories that could be public instead of private, and we're not forcing good authentication, like multi-factor authentication, to these repositories. I mean, this is just basic hygiene 101 kind of stuff, but common mistakes in this environment now exposes, lots of data records in this particular case.
Yeah, and those two things for the human accounts, throwing on that multi-factor of some sort. And there's another point too that this researcher made, is that also had found repositories that had simply been abandoned rather than deleted. So there's also, we can call it, one of our favorite phrases, perhaps, tech debt, lying around, creating a liability. So tech debt is also maybe security liability, if we're looking for some additional synonyms there. But I think, too, there's also, to pull on yet another of John's favorite topics, there were some more bugs patched in Azure Sphere. And this is Microsoft's, basically their IoT in the cloud platform. And these were pretty interesting because they're basically poking around at Linux kernel space and manipulating memory. And in one case, showing how they could change what was intended to be read-only memory and turn it into writable memory, which basically then writable memory gives you command execution. And basically, here's your shell code that you want to execute. Go forth and conquer the IoT and create your botnet. So these are pretty interesting, and again, pretty good write-ups from the researchers from I think Cisco Talos were the ones that found these in particular.
Yeah, I saw this morning. This is interesting. I never got to bang on this as hard as these guys did, so really surprised, because the team who did this stuff, it seemed like they did such a great job. What's really sort of confused me about this is it sounds like Microsoft didn't want to issue CVEs. I don't see a good reason why yet. That doesn't sound like Microsoft. So I'm a little confused on that little technicality. But it's a good example, right? It's again, we think we know how to do this stuff right, and they've gone through a lot of the right process and they've designed it properly, but it looks like implementation flaws. So a good read, and you've got not one but 4 of these things to go through, on all relatively recent versions of the software, of the kernel. But yeah, it's, I don't know, a little. This is still a very new, very young platform. I think hardware's just been out about a year, but still, I still think it's my preferred. If someone will ask me how to do IoT right, I think this is still it. And they'll find these things along the way, so hopefully it'll be a sign of further improvements.
The one thing I didn't realize Microsoft did here was built their own custom Linux-based operating system. Why not just grab one of the ones that have already been through a lot of this validation? Why create your own custom Linux OS at this point, right? That seemed kind of weird to me in this whole Azure Sphere architecture.
So it's super minimal. It's really just a kernel. It's not really an operating system. So that's probably part of it. It's for their own silicon. So it's probably some reasons around stuff like that.
Yeah, I think two things around that are one is as John just mentioned, they have their own system on chip for a lot of capabilities. So I think part of that is they needed a lot of kernel customization. And I also linked in the show notes, they have I think we talked about this in the past, there are 19 cybersecurity best practices. Mm-hmm. And one of the things that they highlighted too is to eliminate the concept of users on IoT devices, meaning like basically root or non-root users, and it's basically just the device. And they actually say in that document that following this particular best practice actually took a lot of tweaking in the kernel so that the rest of the POSIX capabilities could understand that, we don't actually have we don't actually have users to rely on. And so I think that's for those two reasons that those were at least two influences in terms of them going down their own path in designing a good hardened kernel for IoT.
Yeah, but I think the key point here is they had to make a bunch of customizations. And when you do that, you potentially introduce vulnerabilities. Here they are, right? So now you're going to have to put part of this platform, I think, through a lot of regression and security research to say, based on those customizations, did I open up other potential kernel bugs here that I didn't intend to because I had to create my own custom kernel?
That's a great point. And it really speaks to, are they making customizations for convenience, or are they, good security minded, and are they actually ultimately reducing attack surface? Because just as we've seen here with the Azure Sphere, we'll see the same thing in Chrome. Chrome has had, significant RCEs in memory corruption every single month this year, I think, or just about. But obviously they're able to respond quickly and react quickly, and they have a good architecture that reduces the potential impact. So I think here to sort of build that parallel, I want to say that Microsoft is on this path as well, because another thing they also that stands out to me in this cybersecurity best practices, they also mention not parsing certificates in the trusted computing base, basically in the good signed root of trust for their application. And they make a really good case because certificate parsing, for one, based on X509 and ASN.1, notorious bugs from at least 2, if not 3 decades of security bugs have been in there. And you probably don't want to tie yourself so closely to that type of certificate within the TCB. So I think those are some aspects I would point to that they're on the right path to reducing attack surface, or at least they know they should be. But I guess we do have to keep watching to see how much the implementation matches the design and intent.
Yep.
There is also then, speaking of going back to GitHub in this case, GitHub was also in the news. Just they post on their engineering blog, but I wanted to pull this from a security perspective, just talking about how they were upgrading to Ruby 2.7. And I know poor Paul has been struggling, or perhaps wrangling, or whatever the good term's in, wrestling. We need Paul's wrestling name now, with getting, I think, Python updated. But he's not alone. GitHub here isn't alone, just trying to update to the latest supported version of Ruby. And what just stood out to me is they gave a good description of how they went about doing it, basically saying, we're going to have a parallel path for 2.6 and 2.7. Going to roll out slowly, watch to see what happens, do bad things happen, so we can roll back safely, and then just say, cool, now we've at least set up our code so we have a path forward, and we're not stuck on this older version of Ruby as it goes out to unsupported or into just a pure, not even a dormant maintenance phase, so to speak.
Yeah, I mean, Paul made a ton of progress from Python 2.7 to 3, and it's actually running in our staging environment now. It was surprisingly easier than he thought it would be. I mean, there were a couple things, right? The way certain things were changed in Python 3, but we've got a parallel path as well, because now we've got Python 3 running in our staging environment, and as long as that continues to go smoothly, I mean, we'll just push it. But yeah, there's other enhancements in there too. But yeah, he's made a lot of progress. But it's easier for us. I mean, there's how many people that log into our system compared to GitHub, right? I mean, you're talking a massive system here that a lot of people log into. You don't want stuff to break.
Yeah, you absolutely don't want stuff to break. And this also did make me think that you don't want stuff to break, and you also want to know when are these languages, or when are the language versions, the point versions, or the frameworks going to go into become deprecated or go into just a security maintenance phase. And Ruby has pretty good documentation. Python actually has really good documentation about their support. But I think this was more of just, I was mentally thinking what would be a nice call to action is that what would be a standard way or of just so DevOps teams can track, when is this version of Go going to go out of support? And of course, we have seen a lot of the vendors we've talked to, a lot of the open source tools, they do try to keep track of these things in that terms of that software composition analysis.
You walked right into where I was thinking on the Go stuff. And there was a blog post, I ran into this last week. I wish I put it into the show notes, but I didn't. And it was someone ranting about the Go ecosystem. But there was a part in there which was really interesting because, so I think we've talked about, but for those who don't know, the frame of mind of the Go community is developers of both the language and the libraries should, latest is always, and they've just started adding versioning in like really the last year, but the state of language is the latest version is whatever latest and greatest features they have. They are very open to break backwards compatibility, break the contract, and they expect consumers of their components to have the burden of keeping the software up to date with the latest. Once again, at Layered Insight, Matt heard me cursing many times over this when we go and, just go to bump a library to bring in one feature and all of a sudden our build would break. But it turns out the reason why is what's interesting, and it's sort of to bring it back to the Rubies and someone large like GitHub trying to do this change. I guess Google internally has, I think it's sort of known, most of their source code is in a single repo. But they've got these utilities they've written that allow them to model a change in their software. So if they go to change a API or a contract, they can see all the places it's going to change and automatically change all those things at the same time. So that once you have a tool like that, that makes it very powerful for you internally inside your organization, since you've written the language and the libraries, right? For those on the outside who don't have that type of thing, and like I was saying, we go to bump to get a feature or to fix a bug, and we've suddenly broken things. That's where it becomes a problem. But it sort of made that become a little more understanding to me in the Go thing. And like I said, they've started doing versioning, so they've gotten a little better at this. They've gone through vendoring and then versioning and then Gover, and it's still sort of changing, I think. But the one thing which is interesting to bring it back to the GitHub piece, when I looked through this, I was expecting them to say they were using feature toggles for doing that migration, and I didn't see that in there. So I thought that was sort of interesting.
Yeah, I think they were rolling out to more of a canary approach, and as opposed to feature toggling. But still, a good observation and a good point to say, that'd be one of the questions to throw back to the DevOps team. Do you even have a capability to run two parallel versions or be able to do this type of testing? Because if you don't, on the one hand, just feature toggles, et cetera, are just great for the product itself, just feature, as I say, customer-facing features, as I'm trying to struggle for words here, but also features for just testing new deployments, new versions, new libraries, et cetera. So it's a lot safer to roll back, and that gives you, again, go into that concept a little bit we were talking in the first segment, call it resiliency or availability, so that the application is just more robust against failure. I think that also is a kind of a way to bring us into another article that was talking about did your DevOps strategy fail? And this is, again, a bit of a high level article, but it's making a couple good points. One is just saying, have someone look at why, if you're trying to move into this concept of DevOps, for example, you're trying to combine it with a point version for your language upgrade, or adopt something that enables you to run languages in parallel. If you failed, why? And this does go to that idea of that sort of blameless postmortem. But basically, it's saying build that feedback loop. And the other point that stood out to me is that, again, pretty generic, pretty fundamental, but saying it's a collaboration. So if you call it DevOps or DevSecOps, it's security, developers, operations, basically figuring out who's responsible for what within the application, and making sure that the responsibilities are aligned with incentives, as well as the tooling or processes in order to support that more effectively.
Yeah, this article ties in a little bit to the CISO article that you list after this, is because let's say your DevOps process failed. Where did it fail? Is this now an opportunity to collaborate with security and start looking at ways to integrate those other pieces in, right? I think a restart or a failure, when it forces you to kind of do a retrospective and kind of look at your process and say, all right, we got to fix this, but while we're fixing it, maybe we can improve it at the same time and leverage security and some of these other groups to really kind of fine tune the process and enhance it as we're fixing it. And I think that's the collaboration that needs to continue, Mike, in the industry, right? When I talk to a lot of analysts and vendors, I mean, this is a common theme that people are starting to realize, that there is a collaboration effort here between development, DevOps, and the security teams over time. And that then also kind of begs the question, well, what's going to happen to the CISO role, right? Is AppSec going to stay under the CISO? Does the CISO stay in an operational role? These are all questions I raised years ago. And I think they're valid, because if DevSecOps is the future, then a lot of the security operational components goes to that team, and maybe it's not a dedicated CISO role anymore, or if it is, it's in a different capacity. It's not in an operational capacity. Maybe it's more in a governance or awareness or security champions initiative versus what used to be the operation side.
Yeah, that's a great point. It's that CISO for engineering to build the tools, or CISO for governance as the DevOps, as the traditional CTO structure, or the product engineering team is building those tools. And that's what this CISO article, what success looks like. There's a lot of AppSec in there that stood out to me, because on the two things. One was that, what was the quote from it? That this starts with, in the business, investing the time and understanding the security requirements, and then agreeing upon business risk tolerance. Right there speaks to governance, just as you were saying. And that also is very much just threat modeling, as John mentioned right at the beginning of the segment. What are we really worried about, and what should we be worried about? And the risk tolerance part comes in to say, okay, we're worried, but how much do we need to invest? Do we need to be aware of that, or do we need to invest something to bring that risk down? And that's the other part of this article that stood out to me in that sense of threat modeling, is saying, if the board is just saying, oh, hey, we read in the news this hack happened, or this other hack happened, how is that going to happen? Is that going to happen to us? Go protect us from that. That's potentially a little too myopic, because you're kind of forgetting that there's a lot of really fundamental things that need to be done in terms of making sure your credentials aren't hard-coded into your code and being put onto GitHub, making sure you can just do basic inventory of your cloud assets. And then, just as we were talking with Mark in the first segment, what kind of visibility do you have in your environment? So I think, and those parts, I think those are the questions I'm asking that go towards more perhaps that engineering oriented CISO.
Yeah, exactly right.
This is such a hard role. I mean, I don't know if all engineers, I know we have a mixture in our audience. I don't know if all engineers get it. A CISO is sort of it's almost a more political role. It's definitely a more political role. And when I saw the headline in the show notes, my first joke was going to be, successes if they last more than 2 years, and they covered that in the first paragraph, right? It's the CISO in a company. They're that person who has to try and keep everyone happy, right? They report either to a CEO or to a board. They have to, take all the wishes, I'd say, from that group of folks, and then somehow figure out, how do we how do we implement that and apply it to the rest of the organization? What's our tactics like for the next, or both strategies and tactics for the next year or two? About, obviously not want to be on the front page of the New York Times or worrying about the latest shiny marketing vulnerability, but also making sure that the bases are covered. It's a, I sort of want to say a thankless role. It's especially now that in the U.S., I think it's a federal level, right? We have there's potential for the C-level person who is responsible for privacy and security to have legal, and I think that's your next article, right? Yeah. To have potential legal lawsuits personally at them. So it's a tough role to fill and to juggle all these requirements.
Yeah, and that's why I pull these 3 articles. Did your DevOps fail? Let's figure out why. What does CISO success look like? And then perhaps that cautionary tale of this is Joe Sullivan and Uber. And perhaps a misuse, I will say most politely, of a bug bounty program, because we've talked about bug bounty, and it does have a very important place within AppSec. If you're mature enough to have hopefully set up and cleaned out a lot of the bugs, bring in that external bug bounty, have a good vulnerability disclosure program as well, just in general, which is different from bug bounty. But don't necessarily expose yourself to criminal liability by basically using bug bounty to essentially, the claims here is basically paying off a ransom. Or basically, I think more importantly, it's the cover-up, saying that we don't have to report this breach because it was actually reported through our bug bounty program. And look, here's the NDA that was signed and the payments that were made.
Yeah, this is interesting from a legal perspective, and I think all CISOs should take notice, okay? They used the bug bounty program to basically pay a ransom because they didn't want to have to do a breach notification to the government because of the 2014 incident, and this happened in 2016. So they were trying to get out of the Fed's kind of microscope on another breach of Uber data, in this particular case, used a bug bounty program to pay this ransom, basically, and now he's going to get in trouble criminally, I think, at the end of the day. I mean, this is the kind of potential situation as a CISO you don't want to be in. And that's not what these programs were designed for, but it was used in a malicious way.
Absolutely. And there was there's also the aspect of legal, probably, or at least it should be, pulled into any type of important forensic investigation. And off the top of my head, I can't remember what it was, but there was a article earlier this summer about whether that was looking at potentially that legal and I just lost my term of art here, proprietary and confidential, but the privilege, that the legal privilege between the legal team and forensics may not protect you from discovery or from investigations into how a breach happened. So quite interesting too, that maybe that, as John said, maybe the CISO role is becoming as much political and legal as it is on that governance side, as opposed to just purely in engineering, so that we can have a good logging, so we can reconstruct whether or not our data that was leaked into an S3 bucket was accessed, but figure out, what do we now need to do in terms of breach notifications at the federal as well as the state level, since there's almost, I think, 50 different breach notification types of rules to follow. So quite a complex environment that very directly also ties to application security, because this is where those most of the time those breaches are coming from.
Yeah. Yep, it's becoming a scapegoat position almost in some places, so just beware.
Beware, but do listen to Application Security Weekly as well as all the other Security Weekly shows to get good insights on how you can best be a CISO and last more than 2 years of the job. But we'll keep our fingers crossed for you. I want to say thanks for Matt and John for joining me once again to go through the news. Thanks for everyone listening and chatting with us in the Discord. Make sure to sign up for a mailing list. Come join us in Discord. We are going to take a break, I believe, next week, but we will see you next time on Application Security Weekly.